Okay, so we're going to walk through proof number 11 on page 172 for 4.1. Let's take a look first at what I'm trying to figure out. That's where I always start. So we're trying to figure out if AB is equal to DC. And so what I like to do is I just like to, okay, how can I somehow get this piece equal to this piece? And so in the back of my head, this is what I like to do is walk through it. So I either want triangle ABF equal to triangle, let's see, I started at A, so C, D, E, or maybe I'm going to get this bigger triangle right here, triangle ABD equal to CDB triangle. So I don't know which one I want to get, but I do know that both of those triangles, this triangle and this big triangle, contain segment AB. And this big triangle right here, or this little triangle, both contain segment DC. So in the back of my head, I'm going to try and get one of those triangles to be equal to each other. So let's look at the given information. AD is equal to BC, and AF is equal to EC. BD and AF are perpendicular, so we've got some right angles going on. And BD is also perpendicular. Okay. So I am not seeing if I can get this. I cannot, actually. I only have a side and an angle, so I cannot get those equal. Okay. The big triangle, I only have a side and a reflexive side right here. So I cannot get those. Okay. So looks like we're going to need a detour. And once again, I don't know where this is going, but we're going to try what we can because we can. So it looks like I can very easily get this triangle equal to this triangle. And as soon as I did the right angles, I was assuming we'd use hypotenuse leg. And we will. We have the hypotenuse and a leg. And because they're right triangles. So we are going to get this blue triangle right here equal to this orange triangle right here by hypotenuse leg. So statements and reasons. And let's be super. Step 1, given. Super lazy. Step 2, from that information, I can say that triangle ADF is equal to triangle CBE. And that is by hypotenuse leg. Okay, so I have the blue one equal to the orange one. And I'm thinking maybe we should go this route right there, because if that blue triangle equals that orange triangle, then this angle, I'm going to put a number in here, then this angle, angle 1, has to equal angle 2. So again, if those triangles are equal to each other, then angle 1 has to equal angle 2. So angle 1 equals angle 2. That's because the triangles are congruent. So once those triangles are congruent, their parts are congruent. And now I think, let me see. I'm going to erase that. So I have triangle 1 equal to triangle 2. Let's see if we can get this going right here. Because I have a side, I have angle 1, and I have that reflexive side. So I just have to make sure I write that reflexive side down. So BD is equal to BD, congruent, I should say. And that is the reflexive property, which is any segment is congruent to itself. And so that pink triangle, once again, I have this side, BC. I have, which is right up here, BC. I have angle 2 right there, and I have side BD of that blue triangle. So here's my blue triangle, this one, this one, this one, and here's my pink triangle, AD, angle 1, and BD. So now I have enough information to say triangle ABD is congruent to triangle CDB. And my reason is side, angle, side. And if those triangles are congruent, then their parts, like AB and DC, have to be congruent. Okay, so I'm sure there's other ways of doing this, but that's just what I saw as I was approaching this proof. So let's take a look at number 12. Okay, so once again, I just look at what I'm trying to prove. So I'm trying to get angle 1 equal to angle 2, which means I'm trying to get this pink triangle equal to this triangle. So in the back of my head, I'm trying to get triangle PRS congruent to triangle PUT. Okay, so this is what I'm going to try and do. Now let's regroup and see what they give me. So PR is equal to PU. QR, I'm going to denote this with a pink segment. QR is equal to QU. And RS is equal to TU. Okay. All right. I only have, so if I was trying to get these triangles congruent, I only have a side and a side. Side and a side. I don't have anything else, so I cannot get those triangles congruent. So we're going to have to get other triangles congruent to each other. And I feel as though if I draw this line, because I think the shape is weird. So if I draw PQ, so statements and reasons, copy, paste image. Okay, so step 1, given. Step 2, draw PQ. Any 2 points make a segment or a line. And so I can now say that PQ is congruent to PQ, and that's the reflexive property. And now I can say that triangle PRQ is equal to triangle PUQ by side, 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 which is in step 1, and step 3. Okay, so I have those triangles congruent to each other, and so basically I have this orange triangle right here equal to this green triangle. And I'm trying to get the smaller ones equal. Oh, okay, here we go. I can pull out that angle 3 equals angle 4. How do I know angle 3 equals angle 4? Because the triangles are congruent. And if the triangles are congruent, those parts are congruent. And now I have enough information because I have this blue side, I have that blue angle, and I already have RS. And I have this side, this angle, and this side. Yeah, buddy. Okay. So, let me make sure. So I have RS equals UT. I have that. I have PR equals PU. And angle 3 equals angle 4. So everything that you see in blue is going to help me say that triangle PRS is equal to triangle PUT. And the reason is side angle side. And that stuff is in 1, 5, and 1. Once those triangles are equal, then angle 1 has to equal angle 2.